Hello everyone. So today we are going to work on how to create this random voxel world. So here I can randomize the world by pressing this button. So you can see every time I press this button we see a random generated voxel based world. So here we have many parameters created. So X cell count, Y cell count, this would define the size of the world. So for example, if I make it 100 by 100, this doesn't have to be same, it can have a different size as well. You see the size is changed, so I'll keep it 200, okay. So now this is the size we get. And also here we have 4 different types of voxels. One is water, this blue one, and then the beach, and then like green grassy ground, and then rock layer, snow layer on top if you want. So yeah, and here we have this beach size. If I make the beach size smaller, you will see now we have no beach. And if I make it larger, we get a good size beach. We can make it even large if we want. See, so now it becomes almost like a island. Okay, and then here we have this water level. If I make it, for example, 10, you see the water level is high. And if I make it even higher, the amount of land would be even less, like this. Right, so I'll keep it at the base level 1. And then we have another parameter called rock level. So if I make it higher, this black layer would be pushed up like this. So we would have more green. And another thing is, here I have this Berlin offset. So if I disable this randomizing, so let's say we like this layout and we need to keep it. So I can keep this value here, and if I clear and generate, we will have the same grid. So this randomization is related to this Berlin offset parameter. So if I keep it 0, this is what we get for 0. So if I make it like another value, this is what we get. So as long as we don't change this, we would have the same layout in the landscape. But if we want to randomize it, we can just enable randomization and generate many different types of landscapes. Also, we have this gap. So this basically defines the size of one voxel. If I make it 100, now you see this becomes smaller because this cube size becomes smaller. If I make it 500, one cube is larger, so that's why we get this large landscape. So I'll make it 200, and then I have used the third-person template, top-down template, so I can use that character and move around. I feel this is too dark. Well, actually I have a post process for you. Yeah, so alright, so these are the things that I'm planning to do today. And before we get started, I'd like to remind you that you can download the project files of this project and all other thousands of projects that I have done in my channel. To the date, there are over 1700 videos, and for each video you can download the project file. So that would help me to keep doing what I do here, so feel free to check it out. And let's get back to the tutorial. Alright, so here is a blank map for you, and here I have, if I use the top-down game mode, by the way, when you create a project you can either select top-down template, or if not, you can use this add feature or content pack and select top-down and add to the project. So I have already done that, so therefore I have this option. So when I play, this is what I get. Okay, and here I have increased this sprain arm length of the top-down character to 3400, so that's why I see the character in very small, in far away. Alright, so first part is creating the cube in the way we need it. So actually we already have a cube mesh if we want here. Let me drag and drop here, and here I'll set the snapping to 100. So you can see, if I place this in here, you can see this is exactly the size of one of these cubes. But yeah, let me move it like this. But the center of this cube is in the middle. So instead of that, I want a different cube, and I need 4 sides to have a different material slot and top to have another material slot, and maybe bottom also another one. So if I scale this up, let's say if I make this 3, now you see it's scaling up like this, which is not the way I want. I want the base to stay on the ground and only top to move when I scale up. So to get such a behavior, let's go to Blender, and when you create a new file, by default you get this cube. So if I press tab and go to edit mode, let me go to a side view and enable this X-ray mode, so I can select vertices in both sides and enable snapping. So here in this view it's meters. So I want to have a cube that is 1 meter, 1 meter, 1 meter in each dimensions. So I'll move this. I'm in this vertex selection mode. If I select these 2 vertices and press G and X, I can snap them. Here, press G, Z. Here. Right, now this corner is in the middle. So if I go to this view, this is Y positive. So Y. Okay, now this cube is 1 meter, 1 meter, 1 meter. Okay, now if I go to the shading mode, I'll go to face selection mode. This one, I'll name this M sides. So I'll give a color somewhat like this. It looks a bit like a soil color, and then select the top assign a new slot. I'll name it M top. I'll make that green. So it looks a bit like grass. And bottom, so this would be useful if I am planning to have transparent materials for water. So in that case, I need to have I need to see the base in the depth of water. So in that case, in order to have a face when I look at like this, I will have to flip this. So here, let me go back to modeling mode and face orientation. Select this, mesh and normals, flip. Now the face is inside here, see? That's why we see it in this purple like color. Go back to shading, and base is already selected, bottom. I'll add another slot for this. And base. If I mark it a bit dark, so context. Oh, we are in object mode. Edit mode, select this, and base, assign. Okay. Alright. Okay, now our cube is ready. We can export. Yeah, I'll make it voxel. Now I make a voxel and X forward, set up. Here I don't need to have any smoothing, so I'll select face here and export. Okay, now in my project I have written a meshes folder and under meshes voxels. Now let me drag and drop that voxel object here and import. Okay, now this is what I got. So if I set this snapping to 100 and place it, now we see it's exactly 1 unit in Unreal. And also if I scale this, I'll set scaling also to 1. See, it's scaling upward. There is nothing in the down below the base. So that's the way I want it. Okay, so we can directly use this Z scale to define the height of the landscape in Voxel. So I'll call this SM Voxel grass, and if I duplicate this SM Voxel water, so now here into these top I can assign a blue colored material. This one is green. I can easily just duplicate this and assign it, so we will have a blue colored one. And I'll do that without recording because you already know, you can do it yourself. Right, so here I name this SM beach, SM grass, SM rock, and this other voxels. I got grass, rock, water. Okay, now I have a blueprint folder. If you can create one, let's create a blueprint class. Actor, I'll call it pp voxel world. Okay, now so here I'll add an instance static mesh component. I'll call this ISM grass. So as the mesh, I'll assign the grass mesh, and similarly I'll add ISM water, and I'll assign water, and ISM rock, and same rock. This is correct, right? Yeah. What else? Oh, beach. Or sand, whatever you want to call. I'm gonna call it beach. Right, now we have 4 cube types, or voxel types if you may. Now let's add a custom event. Generate grid, and I'll make it I don't need this for now. I'll make this call in editor, so when I drag and drop this here, we get this generate grid, but for now it doesn't do anything. And I'll delete this flow, I don't need it anymore, and save this map. Voxel test. Okay, now here, so to generate a grid we need to have some variables. I'll first define Excel count, which says how many cells we would have in X direction. I'll make this editable, and by default I'll put 100, and duplicate this. I'll call it Y cell count. So the world doesn't have to be square shaped. If I want, I can make it any rectangle. And I would need another one gap that would say the gap between 2 cells. Okay, now so here we would need, when we generate grids, we would have to regenerate. So I'll add another custom event, clear grid. So whenever we need to clear it, we can just get rid of all the cells that we have added. Clear instances. So I'll clear here the instances that I already have. Before we regenerate, we need to make sure that all the instances that we already have is cleared. So I'll make this also able to call in editor, and when we generate grid, I'll first call clear grid, so we will not be regenerating on top of already generated cells. Okay, now you know when we need a grid, we need to run 2 for loops. The outer for loop would be running from 0 to Voxel count, and the inner for loop will be running from 0 to 𝐿 count. So you should be familiar with this pattern if you have followed any of my infinite runtime terrain generation tutorials. If you have followed, because I have used similar techniques in there as well. This is the playlist, if anyone is wondering. It's available freely in my channel. Okay, now for each of these cells we need to add an instance. For now I'll just add a grass instance. Add instance. So here we need to give its transform. So location, I'll make vector, and x will be coming from here, but remember this is going from 0 to cell count. So something that means since I have 100, this will be changing from 0 to 100, and this one also same, 0 to 100. But the location has to be different because the size of one of these cubes is also 100. Is it 100? I don't remember. Here, let me place. Yeah, it should be 100 if I go to the top. So this, see, you can press middle mouse button and drag a line, so it's 100 units, not 1 unit. I think I said in the beginning it's 1 units. Actually what I was thinking is 1 cell in this grid by 1 unit, but in Unreal Units terms it's actually 100. So this gap has to be 100. Okay, now so therefore I will have to multiply this location we create with the gap. So these instances will be added accordingly, and I'll make it a world space. One more thing, if we want to generate the world starting from the point that we have placed this voxel world generator, now it is in the root, so it wouldn't matter. But if it does has an offset, we will have to add back the location. All right. Okay, now if I compile, I'll leave scale as 1114 now, and we don't need this. Voxel world generate grid. Now you see we got 100 cells from here and 100 cells in this way. We got a nice grid. So we don't see the cells because they are fitting perfectly. But if I enable wireframe mode, you can see the grids. So perhaps we should how should we do it? Yeah, we can get the gap and divide it by, I'll promote this to a variable and I'll call it voxel size. So one side of voxel is 100 units. So if I divide this gap by 100, we would get 1. And if I another thing, this Z will define the height of the terrain, as I mentioned before. For example, if I make this 3, you will see, if I generate, I will see it increased elevation compared to before because of this. So here, if I directly connect this, we wouldn't see any difference. See, still we don't see any gap. But if we need to see a gap, we can actually subtract, let's say 0.1, like this. And now we see the gap. May not be, maybe too much. One more thing. Now that I have added voxel size, now let me change this gap. Here, if I make it to 100, now this should automatically increase the size like this. Okay. I think this 0.1 is too much. Yeah, this is better. Alright. Can we work on this? We have a starting position here. We remove that. Yeah, no issue, we have collisions, so we can work on this. Right, now the next step is, instead of having this plane, we need to have different heights. So that means we need to calculate this Z scale. So to calculate height, I want to use a Perlin noise, but we only have Perlin noise 1D in blueprint level. So just to demonstrate this, if I break this vector and add these two together, and for some reason we need to have a very small value like 0.1 or decimal value also in the input for Perlin noise to have a non-zero output. So this return value would be in between 0 and 1. So if I want to have a considerable value, I may have to multiply this with 1000, and I need to divide this with the voxel size to find the scale and put it into Z scale. Right, now generate grid. Now you see we do get a differentiation in height. Oh, this becomes black because the scale becomes negative. We can't have negative scales, so I'll choose the max of 0 and this value, because I don't want to have negative values in our landscape. If it is 0, I want it to be water. Let me make it 1. Yeah, but this does not look good. So, but in C++ level, we do have a 2D Perlin noise function. So, let's go here, and if I regenerate it, now everything is plain. Tools, new C++ class. I'll create an actor and name it Voxel world and create class. Now in order to get the, so here is the code, generated code. This I don't think I want it to tick, so I'll make this false, and you will have to compile this project from here for the first time before compiling from editor. Okay, now it's compilation done. So test. Okay, so now open this blueprint. So here I'm going to reparent this. Instead of actor, I'm gonna choose Voxel world, which is the C++ class we just created. Now here I'll add a function. We need to call this from blueprints, so use function blueprint callable. This needs to return a float get terrain height for a given vec2d for a given location. Right, now let's implement this. Here using this location and in C++ level we do have access to Berlin 2D noise function. So instead of this we can return fmath Berlin noise 2D. Now here we can give the location. So location, and actually that's pretty much all. So now save this, save and go back here, compile. Compilation succeeded. So now we can, since this is a child of Voxel world, we can call get height. Wait, what's the function name we defined? Get terrain height. Okay, get terrain height. Right, now we need to do it like this. So location, as the location I'll give this, and so I didn't add any multiplier here, so let's take this out. This would be in between 0 and 1, so I'll just add a multiplier. 1000. Okay, compile. Now let's see what we get. Nothing. Oh, sorry. Let me directly plug this here. Why is this 0? Still nothing. That might be because of that case I explained before. We have a small value, so vec2d 0.1f 0.1f. Okay, generate. Yeah, see, now we got some interesting pattern. So, and it's also a 2D noise, but this is not very interesting. We need to have mountains and we need to have small details. So how do we change this? For that, I'll do something like this. I'll wrap this in another function in blueprint level. Get height. Okay, and I'll make this a pure function, so we don't have to have this line connected here. Right, now we can have, I'll add 2 additional parameters here, location and another const float scale and const float amplitude. Oh, we need to add these in the function definition as well. And then I'll for the scale, we will have to we can multiply the location with scale scale, and the final result we can multiply with amplitude. Right, now let me compile again. Right, now we have a scale, so we don't need this now. Scale, oh, that's actually amplitude. So a scale is just a scaling to given to this input location. So I'll make it 100. Now let's see what happens. I'll promote this to variable. I'll call it mountain scale, and this one mountain height. Okay, so I'll make this editable so we can change the values from outside and see how it changes. So I'll make the scale 10,000 and height 5,000. Compile. So here we can see mountain scale height. Okay, that's not very interesting. Also, this is still not good enough. Generate. Okay. Oh wait, actually this scale, in order to have, this has to be a decimal value. That's when we get yeah, like this. So if I make it even smaller, now we get this small kind of islands. So this should become, this scale should be a division. So then we have, it makes sense, it makes more sense. Actually I did this in the world generation and I forgot about it. So now we can have higher values. Generate grid like this. If I make it 1 digit less, it becomes like this. Now this 1000 could be like, we can think of it as like boulders, and 10,000 it could be thought of it as mountains. So what we can do is here have another one, and add to it this one. So 1000 and let's say 100. I'll call it boulder scale, and boulder height. These things also can be randomized or changed in the level. Same location. Right, now generate. Now we get some more interesting shape. Okay, so for the scale, if I make it 1000, yeah, this is better. Okay, so now, so even if I regenerate, it's same. Mountain height, let me make it 5000. That's better. Yeah, even if I generate again, it's same. So if we need to have some kind of a randomization, what we can do is here we can into this location, we can add a value, but this should not be random for each time we call this function. So I'll promote this to a variable. I'll call it random offset, and then now I'll just call this Boolean offset. I'll make this public. Now here we have Boolean offset. If I add like 50 here, it changes a bit. 50,000, a lot. Okay, so we can have another variable, randomize layout, and I'll make this public. So if this is true here, when we generate the grid, if randomized layout is true, let me collapse this, randomizing layout. If this is true, we can set this Boolean offset, set Boolean offset to a random value. So random float, that's between 0 and 1. Yeah, actually that is also fine, but we will have to multiply it with a large value, something like this. If not, we are not going to change it. Right, Now randomize layout is here. Maybe I should put it above the Berlin offset. So now each time I generate, we get a different layout from the to the landscape, which is interesting. Now the next step is having different types of cubes or voxels. So for that, here get height, I'll change this function to get height and type. Yeah. So here, let me collapse this part. Here we calculate Berlin noise, and we get the height. Oh, I'll just call it Z. So if this Z is equal to 1, branch, obviously we are returning 1, and then let's return this water reference, ISM water. So I'll just name this output as ISM. Else, let's add another return value. I'll return the set. As the ISM, I return grass. Compile, generate. Oh, we didn't use it. Here, instead of this, I'll use this reference. So we will have here, we have now water level. Nice. So the next step is having a beach, and also we need to define a way to make how large the beach should be. So for that, how do we do that? And beach should be, in my design, the way I think is it should be a constant height. So here let me promote this to a local variable. I'll just call it a set, so we don't have to have long lines. Okay, now before we go to this return, I'll check. I'll have another branch. I'll promote this to a variable. I'll call this water level. So here in range, this is actually in range. Okay, so is it? That's what we are checking. Minimum is, let's say, water level, and maximum I'll define water level plus, here I'll call it beach size. So beach size could be something like 15. So if this is false, I'll return grass. Otherwise, I'll return this should return water level, and this should return beach. So as I said, beach should be 1 above the water level. So water level plus 1, and the ISM is ISM beach. Now, okay, so we got a beach, but we have this pillars like things now. So to prevent that, if it is false, now this is beach, this is water, this is grass. Here I'll set Z with Z minus the beach size, and make beach size editable. So now this should prevent having pillars. Yeah, oh, they are below. That's not good. What can we do? Alright, we can have the max of this, or water level plus 1. No, water level plus 2. Yeah, see, now we don't have anything below ground. Okay, now maybe beach size is too much. Yeah, if I want to increase the mountain size, height. Okay, now we got higher mountains. Okay, now the other thing is having that rock layer. So how? Obviously we need another branch. Maybe not. Let's say if Z is larger than here, from auto variable I'll call this rock height, or maybe rock level. That's better. So what should be the rock level? 10. We can change that. If that is the case, so maybe let's not use a branch. Let's do a select with this boolean. So if this is false, it should be grass. Otherwise, it should be rock. Compile. Now generate. Okay, see, now we got our rock layer. But I think we could use some more grass. So rock level, let's put 20. Yep, that's better. Page size, not enough. 15. Okay. So this is our terrain, voxel terrain. Let's make this twice the size. Okay, so I think that's enough for today. Perhaps I would add some more episodes to this if you guys are interested, like adding some foliage or some other stuff. Just I don't have a longer plan actually, but feel free to let me know in the comments like what else you would like me to cover in here. And here we got the player running around in the voxel world. Okay, so thanks for watching. As always, updated project files will be available for the download in the Patreon page. Link would be in the description below. And if you like to support my work, you can get the membership of Patreon Club. See you in another episode. Goodbye.